Hi everyone. Welcome back to my YouTube channel. Alright, so today we are going to continue with our chapter 5, States of Matter, with the subtopic 5.3, Solid. So, in this lecture, there are a few learning outcomes that we are going to cover for this subtopic, Solid. The first one, we are going to explain the fixed shape of a solid. Second one, we are going to apply the kinetic concepts to explain the following process of number 1, freezing, number 2, melting, number 3, sublimation, and number 4, deposition. And C, we're going to differentiate between the amorphous and the crystalline solids. And last one, we are going to state the following types of crystalline solid with appropriate examples. The first one is metallic solid. Second one is ionic solid. The third one is molecular covalent solid. And the fourth one is the giant covalent solid. Okay, so without further ado, let's get started. Alright. So this is like the example for a crystal. Picture of a crystal. So if you could see the particles within a crystal, you would find that they are actually packed tightly together in an orderly 3D array. So diorang ni, dia punya particle arrangement of the crystal solid ni is a very tightly packed together. Alright. And a unit cell is actually the basic repeating structural unit of a crystalline solid. We're going to look at after this. Alright. So the states of matter for solid. So the symmetry and the regularity of crystals are actually due to the orderly arrangement of their particles. Their shape and everything, their fixed shape, their regular shape is due to the orderly arrangement of the particles. We are going to look at the properties after this. Alright, so now we look at the properties of the solid. So solid particles are arranged closely together and the particles can only vibrate and rotate about the fixed position. They can only vibrate and rotate. Diorang tak boleh actually move randomly or freely like the liquid and the gas. Okay, they are in a fixed position and they are rigid. And they have rigid arrangement of particles and they cannot move freely. Okay, so for the shape and volume of solid, they have a definite shape, size, and volume. They cannot be compressed. Okay, like for example, we have a telephone here. This is a solid, right? So we cannot compress a solid, right? So we cannot compress a solid. It has zero compressibility. Okay. Second one is the solid cannot flow, alright, because the arrangement is too rigid. They can only vibrate, they cannot flow, right? So they cannot move. So that's why the ability to flow is 0. And it has a very high density due to the tightly packed arrangement of the solid. And it only can vibrate about the fixed position. Alright, it cannot move randomly or freely. Okay, so now we are going to look at the process interconvertible between the three phases, which is between solid to liquid, solid to gas, and liquid to gas. Okay, okay, so if we look at this one, we can see that from solid to liquid, it can melt, melting process. And from the liquid phase into the solid phase, we can do a freezing process. Okay, for a solid to become a gas phase, it will undergo the sublimation process, and from the gas phase directly to the solid phase, it will undergo the deposition process. Okay. Last time during the liquid subtopic liquid, we have covered the vaporization and the condensation process. So in today's lecture, we are going to look at the melting, freezing, sublimation, and the deposition process. From solid to liquid, from liquid to solid, and from solid to gas, and from gas to solid. Okay. So let's look at the phase change in solid. There are four. First one is freezing, solidification, melting, fusion, sublimation from solid to gas, and deposition from gas to solid. So we're going to look at all of this after this. Okay? Alright. So now we are going to look at the first process, which is the freezing process, or we can call it as solidification process. The process from a liquid to become a solid. Okay, so when a liquid is changing into a solid, the temperature of a liquid is lowered. Okay, so bila temperature of liquid is lowered, the kinetic energy of the liquid particles decreases. Okay, sebab dia adalah a process from liquid into a solid. Right. So, when that's happen, biasanya kita akan masuk dalam freezer, betul tak? Dalam peti ais kita kan, betul tak? So, the temperature in the freezer is very low, right? So, when the temperature of a liquid is lowered, the kinetic energy of the liquid particles decreases. So, the liquid particles will vibrate at slower rate. Makin lama, dia makin slow. Dia boleh vibrate je. Okay. So, a point is reached when the intermolecular arrangement forces are strong enough to hold the particles together in a fixed and orderly manner. So, maksudnya, lama-lama liquid tu akan vibrate slowly, they will move closer towards each other, and then dia akan sampai at a point in which the intermolecular arrangement forces ni are strong enough to hold the particles together in a fixed and orderly manner, which is known as solid. So, bila dah sampai point ni, we will see the liquid is already freezing. Okay, so that's how the liquid turns into solid through the freezing process or solidification process. Okay, next. We look at the melting process or the fusion process. So, this is the phase change between the solid into a liquid. So, basically, when a solid substance is heated, so they will be able to vibrate more quickly. Sebab ada more kinetic energy kan? Sebab heat energy is supplied to the solid. So they will be able to vibrate more quickly and energetically at its melting point. Okay, and soon enough, the particles will have enough energy to weaken the attractive forces between themselves. So therefore, the particles will be able to move freely. So then the solid will be changed into a liquid. So that is how the melting process is happening. Okay, from solid to liquid. Okay, alright. Next, we are going to the sublimation process. So, what is sublimation process? So, the sublimation process is the process where solid change directly into a gas phase without first becoming a liquid. Maksudnya, dia terus daripada solid ke gas, dia tak akan jadi liquid. Alright. And the combination of intermolecular attraction and atmospheric pressure is not great enough to keep the particles near one another when they leave solid state. Okay, for example, we have the carbon dioxide in solid state, the dry ice. So, it can undergo a sublimation process to form a carbon dioxide gas. Okay, so that is the sublimation process. Okay, next. What is deposition process? So, deposition process is actually the process where the molecules from the vapor state or from the gas state change directly to the solid state. So, it is actually the opposite process of the sublimation. From tadi sublimation from solid to gas. So, deposition process is from gas to solid. Okay, for example, we have from iodine gas form into directly to a iodine solid. Okay, so that's the four process that is happening in the solid phases lah. Okay, ada 4: freezing, melting, sublimation, and deposition. Okay. Alright. Okay, so this is the example lah. Let's look at this one. Dia kata, when iodine vapor comes in contact with a cold surface, it deposits iodine crystal. So at ordinary atmospheric pressure, solid iodine will sublime into gas phase pula. Kat sini di mana solid jadi gas, di sini di mana gas jadi solid. So it's happening here, okay? Alright. Now we are going to look at the structural features of solid. So basically there are two types of solid. First one is crystalline solid and the second one is the amorphous solid. So crystalline solid have four, which are metallic crystalline solid, ionic crystalline solid, molecular covalent crystalline solid, and giant covalent crystalline solid. So we are going to look at all these four types of crystalline solid after this. But before that, we are going to look at the difference between the crystalline solid and the amorphous solid. Okay, so what is crystalline solid? So crystalline solid is a particles that are in orderly and well-defined arrangement. Dia particles or atoms, molecules or ion yang berada pada kedudukan yang fixed. Okay, they have fixed shape. And the particles occupy a specific position. And it is formed when the saturated liquid is cooled slowly. Okay, so crystalline solid is well defined. Okay, for example, we have metal, salt, and diamond. So metal, salt, and diamond are the example of crystalline solid. Okay, this is the rocky candy. So rocky candy is a type of crystalline solids. Very delicious, okay? Alright, so now we look at the amorphous solid. So what is actually meant by amorphous solid? So it is a non-crystalline solid. It has poor defined shape. Kalau tadi dia ada well-defined shape, crystalline solid has a well-defined shape. However, amorphous solid has a poorly defined shape. And it is formed when saturated solution is cooled rapidly. Tadi crystalline solid dia cool slowly. Tapi ni amorphous solid dia cool rapidly. So that's why they lack in orderly arrangement of their particles, which explain why it has a poorly defined shape. Okay, for example, we have charcoal, rubber, and glass. These are the examples of the amorphous solid. Okay, so cotton candy is amorphous solid. Tadi rocky candy is a crystalline solid. Cotton candy is amorphous solid. Okay, so now the question asks, which has a greater density? Crystalline SiO2 or amorphous SiO2, silicon oxide? So why? Okay, of course lah, crystalline silicon oxide. Why? Okay, because crystalline silicon oxide has higher density because its regular structure results in a more efficient packing. So bila dia lagi packing lagi lawa, lagi in an orderly manner, so dia lagi ada high density compared to the solid yang dia randomly ataupun dia lack of orderly arrangement, dia ada lower sikit density. Okay, so that's why crystalline solid has higher density compared to the amorphous solid. Okay. So now, we are going to look at the types of crystalline solid. So types of particles in the crystal solid in terms of forces between them for ionic solid, metallic solid, network or giant covalent solid, simple covalent solid. So, simple covalent solid dia ada dua, satu atomic and satu molecular. So, we're going to look at all these types of crystalline solid and its example. Okay, so first we are going to look at ionic solid. So, ionic solid is a solid that consists of the cation and an ion that held together by strong ionic bond. Okay, so the intermolecular forces is electrostatic attraction between the cation and an ion. So, ionic solid is very hard, brittle, and has high melting point. Okay, So, ionic solid is a poor conductor of heat and electricity in a solid state. So, in solid state, ionic solid is a poor heat conductor and electric conductor. However, in a molten or in aqueous state, the ionic solid is a good conductor of heat and electricity. Okay, kenapa? Sebab bila ionic solid ni in a molten state or in aqueous solution state, diorang has a free moving ion. So kan bila diorang ada free moving ion, they can transfer the heat or the electric from one point to another point. So it will, what we call it, make the solid a good conductor of heat and electric. Okay, in a molten and aqueous solution only. Okay. So for example, we have sodium chloride, magnesium oxide, and calcium fluoride. Okay. So this is what this is the example of the arrangement of ions in sodium chloride lah. So this is we call ionic solid. Ionic solid contoh macam garam tu lah kan. The garam kita tu ionic solid lah kan. Because NaCl kan. Okay. Alright, so ionic solid dia arrange macam ni lah. Okay, dia ada lattice point dia. Okay, lattice point. Okay, lattice point ni dekat hujung bucu-bucu ni. Itu lattice point dia. Okay, this one ada banyak lattice point. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, yang paling banyak lattice point siapa? Between ni dengan ni. Saya pun tak sure. Okay, tapi tak apa. Yang ini kita tak explain more detail for this part. Okay, alright. So, the question for this one, dia tanya kita, why ionic solid is hard but brittle? Brittle tu apa? Mudah macam pecah lah, mudah rapuh. Bila kita, when we apply some forces onto the ionic solid will tend to like crash or broken. Why? Okay, so let's look at the arrangement of ion before the displacement. Okay, this is the arrangement of the ionic solid, right? It shows the opposite ion attracts each other, which make the ionic solid hard. However, when some forces apply, okay, ada displacement, jadi kita terketuk sikit. When some force apply, okay, it disrupts with the arrangement of the ionic ion ni, of the, what we call it, ions ni. Tadi kan dia dah arrange nicely, the cation attract with the anion, but now when some forces apply, dah displace some of the ion dekat tepi sikit kan. So sekarang ni dah ada repulsion pula. Dia punya layer tu dah slides kan. Dah ada repulsion between ions of the same charge. So crystal tu akan crack or we call it brittle. So that's why ionic solid is hard but brittle at the same time. Okay. Sebab apa? Bila force applied onto this ionic solid, the layer will slides and will what we call it, make the ions of the same charge repulse with each other. So they can crack this too. Okay. Alright. Now, kita nak pergi pula to metallic solid. So metallic solid, they consist of the positive ions of atom held together by a surrounding sea of electrons. So this is metallic solid, is very strong, okay? So dia adalah a positive ion of atom held by the surrounding sea of electrons. So atoms are held together by strong metallic bond. Dia ada soft to hard and low to very high melting point, depending on the type of metal lah, the type of what we call it, element lah, sodium ke, magnesium ke, aluminium ke kan. Okay, and metallic solid is a very good conductor of heat and electricity. Kenapa? Due to the delocalized sea of electron tadi. Okay, and dia juga malleable and ductile. Okay, ductile tu the ability to be drawn into a wire. Malleable ni, the ability for the metallic solid to change its shape, to form a new shape lah. Kalau kita ketuk dia, dia akan form a new shape. Okay, dia boleh change shape. So dia malleable and ductile. Okay, for example, kita ada sodium, zinc and ferrum. So these are one the examples of the metallic solid. Okay, so now we have a giant covalent. So what is giant covalent? So giant covalent solid are solid that are atoms that are held together by a strong covalent link and forms network. So it's very hard, it has a very high melting point. So giant covalent solid ni is what we call it is the strongest strongest solid lah, sebab dia held by strong covalent link. Okay, sebab dia held together by strong covalent link and they form network. Dia macam ada shape dia yang tersendiri. Okay, dia ada shape of network yang tersendiri and dia very hard and very high melting point. And however, the giant covalent solid ni dia usually poor conductor of heat and electricity. For example, kita ada diamond, graphite and silicon oxide. Okay. So this is what we call it strongly link of a network lah, macam ada network of covalent bond dekat sini. Dia ada covalent bond between the molecules and diorang bergabung lah. Okay, bergabung kat situ macam yang hari tu kita belajar yang shape of water tu kan, lebih kurang macam ni lah kan. Nampak kat situ. So dia ada network kat situ. So menyebabkan dia adalah sangat-sangat kuat. Okay. Alright. So the diamond ni actually it's from carbon. It's a carbon atom that is covalently bonded together to form a network. Okay. Graphite pun carbon atom juga. Okay. Okay. Now dia tanya kita, compare the structures and the properties of C allotropes, diamond, graphite and fullerene. Kita tiga-tiga ni dia ada a giant network lah kan. So kita tengok diamond. So diamond ni, each C atom is tetrahedrally bonded to 4 other carbon atom. Dia macam case water tu, dia boleh tetrahedrally bonded to other carbon atoms kan. And then however graphite ni, carbon atoms is arranged in 6-membered ring and form layers. So diamond dia form macam tetrahedral. So dia boleh form macam apa? Hexagon kan? Macam diamond macam tu kan? Tapi graphite ni dia macam lepeh lah. Dia 6-membered ring, dia form layer. Okay, between layer tu ada van der Waals forces. Okay. So diamond ni dia ada high melting point sebab dia ada strong covalent bond and ada network structure. Okay. And dia merupakan hardest substance yang kita belajar. Diamond is very hard. Okay, and it's normally used as a cutting tools and grinding tools. Okay. So all valence electron used in bonding, so dia tak ada no free moving electron, so dia tak conduct electricity. Okay, however graphite, so graphite ni, the layers of graphite are held by weak van der Waals forces, London forces tu. So dia allows the layer to slide past each other. So it's very soft actually. So graphite contohnya macam ubat pensel awak tu ataupun awak punya pensel kayu awak tu kan, yang warna hitam tu kan, graphite lah tu. Okay. Alright. So it widely used as lead in the pencil and lubricant. Okay, so in each carbon atom, there is one electron unused in bonding. So that's why dia ada free moving electron and they can conduct electricity. So that's the difference lah between the diamond and the graphite tadi. Although they are made up of the same element, carbon, tapi since the way it is formed is different, so making it has different properties. Okay. Alright, so fullerene pula. So fullerene is another allotrope of carbon found in 1985. So another name is buckyball or Buckminster fullerene. Okay, it's shaped like a soccer ball. It has 20 hexagonal faces and 12 pentagonal faces. Okay, so fullerene is discovered by Harold Kroto, Robert Curl and Richard Smalley and won a Nobel Prize winner in 1996. The year where I am born is 1996. Itulah. Okay, ignore me. Okay, so what is the application of fullerene? So, dia sangat-sangat high temperature superconductor. Dia boleh guna as lubricant, catalyst, materials, drug designing. Okay. So, the fourth, tadi 1, 2, 3. The fourth crystalline solid is simple covalent. So, simple covalent ada dua tadi kan? Kita ada atomic solid and molecular solid. So, we look at the atomic solid first. So, the atomic solid atoms are held together by weak intermolecular force, van der Waals forces. So, it's very soft and have very low melting point. And it is also a very poor conductor of heat and electricity. So, for example, argon, neon, rubidium, Rn apa? What is Rn? Rn, radon, Rb, rubidium. Okay. So, simple covalent molecular solid pula, the molecules are held together by intermolecular forces, either van der Waals or hydrogen bond. And the strength actually depends on the polarity of the molecule lah. Kalau dia ada polar, biasanya dia akan form hydrogen bond lah kan. Okay. Dengan dipole forces. Okay, lupa dipole forces. Okay. So, it's fairly soft and it has low to moderate melting point. Okay, and it also is a poor conductor of heat and electricity. So, for example, carbon dioxide, oxygen gas, P4, S8, SO2, H2O, okay. So, dia untuk 6 polar dengan polar molekul, dia ada dia punya type of solid dia adalah molecular solid, okay. Okay. Alright, so okay, sekarang kita nak check what is the types of crystalline solid for the respective example. So for Sn, Sn is a metal, so dia ada metallic. Dia adalah metallic solid. Silicon, network covalent. Okay, ingat silicon dia boleh form network giant covalent tu, okay. Xenon dia atomic covalent bond. Cholesterol dia molecular covalent bond. KCl is ionic, K plus and Cl minus. So, nickel is metallic. Dia pun molecular, fluorine gas. SiC dia network covalent. Nampak silicon dia memang network covalent, okay. And A2SO4 ionic between Na plus dengan SO4 2 minus. And SF6 is a molecular covalent bond. Okay. So now we are going to compare the properties of solid, okay, between molecular, metallic, ionic and covalent network. So molecular covalent solid, dia ada low melting point, dia soft and brittle and dia cannot conduct electric and heat. Okay. So metallic solid, melting point dia varies, dia boleh ada low to high and dia malleable and dia conduct heat and electric. Okay, ionic solid, it has very high melting point. It's hard and brittle and dia tak boleh conduct electric and heat in a solid state, but it can conduct heat and electricity in a molten or aqueous state. And the covalent network has a very high melting point. It's very hard and dia tak conduct electric and heat. Okay. Alright. So we have done for this one. Okay. So sekarang ni the quiz time. So what you are going to do is you are going to answer this question in the comment section below. So attendance will be what we call it will be take from the answer that you given. So kalau siapa-siapa yang tak answer this question, so I will consider you're not what we call it watching the video lah. Okay. Alright, so the question is the diamond and carbon dioxide are covalently bonded. So dua-dua dia orang ada covalent bond lah. However, diamond is harder and melted at higher temperature than solid carbon dioxide. So, explain in terms of types of solid and its intermolecular forces properties lah. Tadi kan kita dah explain apa benda itu. Diamond tu types dia apa, type of solid dia apa. Carbon dioxide tu type of solid dia apa kan. So, kita nak explain lah kenapa diamond ni dia harder and ada high melting point compared to solid carbon dioxide. So, answer the question. Dia ada 4 markah untuk soalan ni Kalau you bagi tahu types of solid for carbon dioxide 1 mark. Bagi tahu types of solid for diamond, dia ada apa? Diamond ni apa? Dia metallic, ionic. Tu satu markah. And then you explain dia punya force, dia punya intermolecular forces properties dia. Maksudnya macam dia apa? Link, dia ada network apa bagi tahu dia sudah bagi tahu pula dah jawapan dia kan. Okey, tak apa. Awak boleh jawab sendiri dekat dalam comment section below tu. Kalau tak faham, ulang siaran. Apa tu orang cakap? Rewind balik video ni. Play balik video ni kalau tak faham lagi. Kalau tak faham juga, baru tanya saya, okay? So, I think that's all for today. Yeah. We are going to continue with the next subtopic 5.4 phase diagram next week. Okay, so thank you for listening and watching this video. Okay, that's all. Okay, bye-bye. Assalamualaikum warahmatullahi wabarakatuh.